Question 5, we have a graph, and we do our Oizerga. The origin is located here. 5, 4, 3, 2, 1, 0. That is the 0, and the 0 is there. So that's our origin. Y-axis is velocity in normal units, x-axis in time in normal units. So therefore, any questions about velocity and time will be read off the graph. The gradient or slope is delta v over delta t, which is the acceleration. And the area, v delta t, is going to be delta x. And that's meters per second times seconds, gives us meters. So we have a cart, we're told, is traveling across a horizontal surface, collides with a wall. The cart's velocity is a function of time. So if we look at what's happening, the cart's at rest, someone accelerates it, it's moving at relatively constant velocity. And the velocity rapidly decreases, looks like while it's hitting the wall. And then it has a negative velocity. So interpreting this graph is, this is impact, and this is bounces off. And this is heading away from the direction, away from the wall. And then it looks like maybe someone slows it down, and it's got a velocity of 0. All right, so if all frictional forces are negligible, which data from the graph to use to determine the direction of the net force exerted on the cart? So immediately when it says net force, we should be pulling out our formula, equals ma. Well, the direction of the net force, it should be the same as the direction of the acceleration. And the acceleration, we observe, is 0 slope, since acceleration is the slope. And here we have this negative acceleration when it's in the wall. And so we have negative acceleration, so it would be negative force. All right, so back to the question. Determine the direction of the net force and the direction of the change in momentum of the force. Well, if F net delta t is the definition of the net force is delta p over delta t, then the direction of the net force is the change in momentum. So what we have is the direction of the acceleration is the direction of the net force, and the direction of the net force is the direction of the change in momentum. So if we look at the slope from A to B, that looks like that's the right answer. The area is delta x. That's not going to help us. The difference in speed doesn't give us direction because it's not a vector. And the graph cannot be used to make the determination. Well, it can be used to make the determination. We've already established that. All right, because that will provide information about the acceleration of the cart. Choice A. Now, it's very helpful in these questions is that as soon as a quantity is listed, to write down the formulas that are related to it. F net. And as soon as they mention change in momentum, we can write change in momentum, but also in terms of the other one becomes very helpful.